Everyone. I'm Nick, and I'm excited to share our work on hierarchical world models for humanoids. This work is a collaboration between UC San Diego, NYU, and Meta AI. Full-body humanoid control is challenging due to the high-dimensional nature of the observation and action spaces, as well as a general preference for motions that appear to be more human-like. However, designing a reward function that accurately reflects these natural human motions is very challenging. For example, even designing a reward function for the simple task of just standing upright is pretty non-trivial. For more complex tasks that involve whole body coordination, vision, object interaction, describing such natural behavior in code is extremely challenging. In this work, we aim to learn natural and human-like control policies using a combination of simple task rewards that may measure the task proficiency, and then regularizing the policy via large-scale human mocap data. Our proposed algorithm that we call Puppeteer is a hierarchical world model that consists of two agents. First, we have a tracking agent that tracks reference motions via joint level control. And then we have a puppeteering agent that controls the tracking agent via low-dimensional spatial commands. These spatial commands are the 3D relative positions of the head, hands, and feet, much like when a puppeteer controls a puppet. We first train the tracking agent to track randomly sampled clips from a human mocap dataset. Then we freeze the model weights and subsequently train task-specific puppeteering agents for each of the downstream tasks. Importantly, the tracking model is universal, and a single checkpoint can be used across all of these different downstream tasks. To evaluate our method, we propose a benchmark for visual whole body control. Our benchmark consists of 3 basic locomotion tasks that do not require vision, as well as 5 visual tasks in which the humanoid does need vision, and in these tasks it needs to traverse randomized terrain using its vision. We base our hierarchical implementation on the TDMC2 world model, and we compare against both a non-hierarchical version of TDMC2 as well as other popular methods such as soft critic and Dreamer v3. Unfortunately, soft critic and Dreamer v3 does not achieve any meaningful performance on even the simpler task that we consider, so we exclude those in the remaining evaluations. We generally observe that Puppeteer closely matches the performance of the TDMC2 baseline in terms of rewards, but it produces far more natural behavior. Here's a comparison of Puppeteer and TDMC2 on the hurdles task. We also see a similar result here on the stairs task. And in the gaps task, we also see a more unnatural gait for the baseline than for our method. In our work, we ask 51 human subjects to compare the naturalness of our method and TDMC2, and we observe a pretty strong preference for motions generated by Puppeteer. If you're interested in learning more about our project, please scan the QR code shown on the slide here or visit the link below. There will be paper, code, models, everything available. Yeah, thank you so much for listening.